Okay, so in this video we're going to take a look at the integration of fractions by using the natural log method. So as always, we'll look at a general formula first, and then we'll take a look at a few examples. So, the integral of the derivative of a function divided by the original function with respect to x can be given by the logarithm of the absolute value of the function f of x plus our constant of integration, from this being an indefinite integral. So this says that if we can identify on the denominator a function that when you take its first derivative is on the numerator, that means that its integral can be given by the natural log of the function on the denominator. So let's take a look at our first example. So in our first example, we're asked to find the integral of tan of x with respect to x. And at first glance, this seems to have nothing to do with this formula whatsoever. However, if we think back to our trigonometry, we know that the tan of x can be given by the sine of x divided by the cosine of x. And now this is beginning to look a bit more like what we have up here. However, the derivative of cosine of x is minus sine of x. So in order for us to have minus sine of x on the top, we need to pull out or add in a minus sign. Here. And the reason we do this is just to make sure that this equal sign remains true. So minus and minus is a plus, sine of x is equal to minus minus sine of x. And by doing this, we've manipulated the fraction to be in this form as well. So this means that we can directly apply this formula to what we now have. So we still need to keep this minus sign, so this is going to be equal to minus the natural log of the absolute value of our denominator here of the cosine of x. And as always, with the indefinite integrals, we need a plus constant of integration. And again, by using our trigonometry and the rules of logs, since 1 over cosine is equal to the secant of x, this can also be written as the natural log of the secant of x. So by using the natural log method, tan of x became a lot easier to handle. Let's look at a second example. So in the second example, we're asked to find the integral of x, or 7 plus x squared dx. So just to break it down a little further, our f of x in this example is equal to 7 plus x squared. So therefore our f prime of x that we can apply to this formula is equal to 2x. So it's almost in the format that we desire, however there's a 2 on top here. So we need to place a 2 on top of here. And in order for us to do that, and for these two things to remain the same, we need to add a half in. So as you can see here, these two expressions are exactly the same. However, now we can apply directly our natural log method to give us a solution. So therefore this must be equal to, the half remains where it is. We have the natural log of 7 plus x squared, and as always in an indefinite integral we need a plus constant of integration. So let's look at a more complicated example now. So in this example, we're asked to find the integral, or the antiderivative, of 5 divided by x times the natural log of the absolute value of x with respect to x. In this example, it's quite difficult to see that in the denominator we have the derivative in the numerator. However, this is the same thing as saying 5 times 1 over x on the numerator and just having the natural log of the absolute value of x on the denominator. And we know that the derivative of the natural log of x is 1 over x. And since we have a 5 in the front, which is a constant, we can just pull that out. So that's the same thing as 5 times and now we can directly apply our natural log method. So we have that this is equal to 5 times the natural log of our f of x, which in this case was the natural log of the absolute value of x, plus, as always, the constant of integration from an indefinite integral. And it's as easy as that. So to summarise what we did to use the natural log method, we firstly had to identify the fact that we had f of x beneath f prime of x in the fraction that we were given inside the integral. Once we identified that it was in this form, we then manipulated it so it was exactly in this form. And then once we'd manipulated it into the form that we wanted, our last step was to substitute and to solve. So as always, if there are any questions, please feel free to pop them in the comments box below. In the next video we're going to continue our integration with fractions by looking at some fractions that we can't apply this rule to and using partial fractions. We'll see you there.